Hi, and this is the PhysicsHigh podcast. A quick quiz. Do you A, want to be inspired by science communicators? B, want to learn all about science education? C, want guidance on your scientific journey? Well, how about D, all of the above? Now, my guest today, I suspect to many of my listeners, needs no introduction, and I'm honoured to chat with Dr. Brian Schmidt. Now, he is a world-renowned cosmologist who in 2011 was awarded the Nobel Prize for his work on measuring the expansion of the universe. Now, he's won numerous awards on top of the Nobel Prize: the Dirac Medal, the Niels Bohr Institute Medal of Honour, and the Companion of the Order of Australia, just to name a few. And in 2012, he was elected as a Fellow of the Royal Society. And in 2016, he was also appointed as Vice Chancellor of the Australian National University. Now, on top of his work in astrophysics, he's a keen advocate for science, especially in regards to public education and funding for scientific and medical research. And as a result, he's often called on to share his views both in the media and also at the governmental level. So welcome, Dr. Schmidt.
Good afternoon, Paul.
So you are very well known in the scientific community, especially in the astrophysics field, but just on the off chance that there are some students or some teachers or educators who aren't familiar with your work, can you give us a little bit about what you do?
Well, I'm an astronomer and I'm an observational astronomer, and I study many things, but the thing that I'm most famous for is looking back in time at exploding stars we call supernovae, using them to measure how fast the universe expands back in time, and discovering that the universe was doing something crazy. Gravity was speeding the universe's speed up rather than slowing it down like we thought it should be doing.
That process started in 1994. You were really interested in examining the slowing down of the universe, and in your work really is looking at, as you mentioned, the study of the supernova. Can you tell us a little bit more about the surprising result you got and how you used supernova to measure that?
So back in 1929, Edwin Hubble realized the universe was expanding. What does that mean? It means everything in the universe is moving away from everything else. And we see this because when we look at galaxies, every galaxy is moving away from us. And the further the galaxy is away, the faster it appears to be moving away from us. And if you take a balloon and you put little dots on a balloon and you blow the balloon up, you'll see that every dot on the balloon, the surface of the balloon that you put, as you blow the balloon up, every one of those dots will move away from every other dot. And the further those dots are separated on the balloon, the faster they move away. You can go use a balloon, convince you that's true. So the universe is sort of like a blowing up balloon. And so what I did when I moved to Australia is I used supernovae, these exploding stars, because they're bright. And I can see them all the way across the universe. I can see them literally 10 billion light years away, meaning that it takes light literally 10 billion years to reach us. So I can look way back in the time. The other thing that's useful in addition to these things being bright, is we know intrinsically how bright they are, how many watts they are. And so by comparing how bright they appear here on Earth and how bright they really are, we can measure the distance by using Newton's inverse square law that many people will have studied in high school physics. So essentially, it just tells you that a light bulb gets fainter by the square of the distance. The other thing we do is we look at the supernova and we look at the color of the light. And from that, as the universe expands, light as it travels through the universe gets stretched. When it gets stretched, it goes redward because the wavelength of light is essentially how far apart those little wave peaks are, and red light has further apart wave peaks than blue light. So the light gets stretched by the expanding universe. So I measure the distance, I measure the redshift. If I divide those two things, that tells me essentially the rate that the universe is expanded between here and the object I'm looking at. So I do it to nearby objects, I do it to really distant objects, and I see what the universe has done in between. And when we did that, something we did in 1998, we saw that the universe was expanding slower in the past and had actually sped up over time rather than slowed down.
So this idea of an accelerating universe expansion really had a profound change on how we view the universe. Is that correct?
Well, the first thing, the reason my sales pitch to come to Australia, because it took me about 4 attempts to get a job here at ANU, was I am going to measure and to figure out the future of the universe. So if the universe is getting bigger and bigger over time, faster and faster, that's what acceleration means. It means the universe is going to last forever, right? It's not going to slow down, stop, and go in reverse and, end as it began. It means it just puffs up, getting bigger and bigger. It means, quite amazingly, that in the future, most of the universe that we see now, almost all of the universe we see now, will be so far away we won't be able to see it anymore. And so cosmologists of the future, like me, will actually have to be studying planets in their own galaxy, because there will be the only thing they're going to be able to see in the future. These distant galaxies I study, they're gone. They'll be so far away, light will no longer be able to reach us.
It has even more of almost a fatalistic bent too, because ultimately, as it expands, we're not creating any more new stars and matter and so forth, and eventually my understanding is that all the stars will die out, and then even though the black holes will eventually evaporate away, though we're talking about trillions of years in that case.
Yeah, in the very, very distant future, you're right. Even the planets in our own galaxy will disappear. The black holes will disappear. The stars will all be gone. And we think that even the individual atoms will evaporate out into space, become isolated. And there's reasons to believe that even things like protons might decay given enough time, in which case you will literally have individual photons that are all in their own in the universe, and that's it. But that would be, trillions upon trillions upon trillions of years in the future.
I draw the attention to Katie Mack's book on that, where she discusses that, which is an excellent book.
Yeah, and she used to be here in Australia, of course. So great. That book is a great thing for people to read.
You therefore won at least you shared the prize, the Nobel Prize in 2011, and as a result, your fame has grown. As in some interviews saying, you've become a bit of a physics superstar sort of thing. It's always been a big change for you in your family. But my understanding on a lighter note is that you were traveling to the United States with your medal, and you had an interesting experience.
I did. So a Nobel Prize is, well, I have a replica of my Nobel Prize. So this is my Nobel Prize. So it's a pretty good size thing. Now the real one, the one that's in Questacon, if you ever come to Canberra, is made out of gold. And for those who know their physics history, the way that the atom was discovered by Rutherford in his lab was using gold because it's so dense. And so when you try to shoot X-rays through gold, nothing gets through. None shall pass, right? So I had been visiting my grandma in Fargo, North Dakota, where she lived. She's passed away a few years ago now. But it was 2012. I had visited her. I was about to leave. I was going through airport security to depart. And I had the Nobel Prize in my laptop bag. And the guy kind of saw it go through and he looked at it funny. And I kind of looked around the screen. I saw the big black circle. And I said, oh, I know what that is. And he said, there's something in your bag. And I said, yes, I think it is this. And I showed them a little box. And they said, what's in this? And I said, a large gold medallion. And the guy looked at me and said, okay, can you open it? I opened it up. And he said, what's it made out of? And I was like, gold. Large gold medallion made out of gold. Who gave this to you? I said, the King of Sweden, actually. Why did he give it to you? Well, because I helped discover that the expansion rate of the universe was accelerating, at which point he was beginning to get rather annoyed. And I said, see, Alfred Nobel Prize. And he said, why do you have a Nobel Prize? I said, because I am a Nobel Prize winner. And then he looked at me and he said, why are you in Fargo? And that's where we finished our conversation.
Let's talk about you. Now, my understanding is your interest in science started really early. My understanding is you were an only child and your father was doing a PhD in biology when you were growing up. Can you tell us a little bit more about your interest in science in those days?
Sure. So, my dad started his PhD when I was 3. And my mom was working to try to make sure we had enough food to eat back then. And so my dad had to take care of me. And so many funny things have occurred during that time with my father working on his PhD and also, taking care of a 3-year-old. And I tell the story of one of these things where he had to go out and collect insects. It's quite remarkable what's in a ditch. And so he went through and we had this big old Buick Skylark, which people here in Australia won't understand, but think of it as something like a big old Holden Kingswood. It'd be like the moral equivalent of Kingswood, okay? And we had this big butterfly net, which we stuck out the window into the ditch. And then my dad drove at about 20 kilometers an hour with me holding the grim death onto this butterfly net as it swept through the grass. And at the end of it, I remember getting out, and there was like, you would not believe the insects in this thing. It was just full of insects, including all sorts of stuff you couldn't ever imagine was there. My dad was good like that. I also remember my dad had was doing something with rats, and his rat got sick and died. My dad had tried to give it mouth-to-mouth resuscitation. And anyway, it didn't work. And my mother came in and my dad gave my mom a kiss and said, what have you been doing? So I've just given mouth-to-mouth resuscitation to this rat. My mother was not amused. But anyway, yes, it was good fun.
And then your interest started, well, at least your 6th grade teacher had something to do with introducing you to astronomy.
Yeah, well, I mean, I was always interested in astronomy. Comet West 1975 really piqued my interest. I got a telescope then. And so I was kind of interested in it. But in 1979, in Helena, Montana, capital of the state of Montana where I lived, a total eclipse of the sun came through on the 26th of February, 1979. I remember it to this day very well. And so the teacher realized that I was really into this thing. And so instead of her teaching the class about this, she had me teach the class about this. And she spent a lot of time helping me and learning, getting me to take it really seriously. And in the process, of course, I learned a huge amount because you got to really learn things to teach things. And so that was actually a great experience because she wasn't super confident in science. But, in that sense, for me, it was a great experience. And hopefully I did an okay job to the other kids with my enthusiasm.
Now, as you mentioned, you were born in Montana, you spent some time in Alaska, then you did your degree at the University of Arizona, and you did your PhD. Then in 1994, you decided to move to Australia. What prompted that?
Well, ultimately, it's because I got a job at Mount Stromlo here at ANU, which is, one of the top 10 departments in the world. So for me, it was a great job. But I had married an Australian at Harvard. But to make things more complicated, I spent 6 months in Australia as a 13 and an 18-year-old, because my uncle immigrated, my mother's brother immigrated to Australia in 1973. So had a pretty good connection to Australia. Great place to do astronomy. I had applied to 40 jobs. My wife had applied to jobs. And my wife's an economist, so we met at Harvard, and it turns out it's easier to get a job as an economist from Harvard than as an astronomer from Harvard. But we both managed to get jobs here in Canberra. So I applied for my 4th time at ANU, got my job on my 4th go. My wife applied for 6 jobs in Canberra and got all 6, including 2 jobs at ANU. So I kind of knew my place in life, but for me, it was a great job. So we moved here at the end of 1994.
And then obviously that set you a long road in the world of astrophysics, obviously with the Nobel Prize in 2011, numerous awards on the way, as I've noted. Though in 2016 you became the Vice Chancellor of ANU. Now, the way I thought about it is like me as a high school science teacher deciding to become a principal of a school. What prompted you to take up that role?
Yeah, well, when you win a Nobel Prize, your life is kind of shocked, and you're suddenly doing talks on TV, meeting prime ministers and presidents, and one of the features of it that is hard is the thing that you love to do, which is to do science. And you can't do science 5 minutes a day or 10 minutes here, 10 minutes here. You need to really sit down and do it, weeks at a time to really think and get things done. That's taken away from you because you have so many things and good you can do and talks you can give that you end up not being able to do that science that you love for a little while. And so after a couple years of doing that, I was thinking about the future of ANU, the National University of Australia, and I was worried that the National University was on a path to just be another university. And ANU has produced, in addition to my Nobel Prize, it's produced three other Nobel work that created three other Nobel Prizes. Peter Doherty, among the other most recent one, but Eccles, and then quite a famous economist who invented game theory. His first paper was here at ANU as well. And it's only Barry Marshall and Robin Warren at UWA. That's the only other Nobel Prize done in Australia. So 4 out of Australia's 5 university Nobel Prize here at ANU. Did we really want to have it just become like any other university? I was trying to find someone who would really focus on keeping it to be the national university, a little different than everyone else. And I couldn't find anyone who wanted to become vice chancellor. And at some point I just decided, well, okay, this will be different. Never anything I really wanted to do, to be honest, but someone's got to do it. So I, put my hand up, and the chancellor and committee at the time were prepared to take a very big risk, right? It's a big jump going from professor to running a billion-dollar organization. And it's been kind of like I expected. I did not expect COVID-19. And if someone had told me COVID-19 was going to happen, I would not have taken the job. But anyway, COVID is here, and away we go.
Clearly, science advocacy is really important to you. You donated $100,000 of your Nobel Prize money to the Academy of Science to start Primary Connections, which I use at our school, which supports primary school teachers in science. You are obviously gifted to speak at a variety of audiences, not only before your Nobel Prize, but also afterwards. In fact, I've benefited from that when I heard you in 2012 during the solar eclipse in Cairns. So clearly, science communication is important to you. Why is it important to you?
Well, I think part of science, it's sort of if a tree falls in the forest and no one hears it, did it fall? Well, clearly it did, but does it matter? Well, actually, it probably does matter. But if a scientist makes a discovery and no one knows about it, does it actually matter? And I would argue, no, it really doesn't. If someone rediscovers your stuff and gets all the credit, that's actually your fault because you didn't tell your story. So I think it's really important to get out and tell the story of science, because that's how you have good come from science. If you think about Australia's ability to counteract the COVID-19 pandemic, partially it's because our public has trusted the science behind COVID-19 and public health, many of the officials here at ANU. And so that trust comes, you can't just, turn it on instantly. You got to have an ongoing conversation. You got to treat the public as your friend, but as someone who needs to know. And it's not, you don't proselytize to them. You need to talk to them and find out and interact and listen to them. Not say, this is the way it is, take it or leave it, but rather, well, let's talk it through. This is how I think about it. And so I really think it's important to tell the story of science so that the beauty of it can be shared, but also the benefits of it can be shared.
Now, science communication has two coins. There's an educational aspect to raise the new scientists of the future, but also into sort of increasing scientific literacy in the community at large. How do you think we're going, and what are the challenges that we still face in terms of that?
You know, compared to my homeland, the US, we're doing brilliant. Compared to what we are used to in the past, it's a trajectory that's downward. So let's talk about producing the future scientists. I think we do reasonably well in that for people who are from educationally advantaged households. I think if you're from a pretty well-off household, go to a good school, you will have, and you're interested in science, you're going to have a lot of chance to get good stuff. This program, good schools, good people in your schools to talk to as fellow students. But I do think there's a fair bit of distance for people who have less than perfect family situations on rural regional areas where they might not have a dedicated science teacher like you there. So I think those are the places we do need to be thinking and working on. And I think there is an issue in a lot of those schools of not having a dedicated science teacher. And I'm afraid a good science teacher adds a huge amount of value, right? Even for me, having a dad with a PhD, I learned all of my science, not from my dad, but from my really dedicated teachers. So we really do need to get sure that everyone has access to a great science teacher. And we can use technology to help that. But just saying, oh, sorry, guess you grew up in the wrong town, that's not okay. So I think we need to sort that out. For general scientific literacy, the challenge is that the information's there. I mean, the problem is there's lots of bad information, a bunch of false information. And so again, people need to have the literacy enough to pick out the wheat from the chaff. And there's so much chaff out there. I think people get lost. And one of the problems of the internet is people choose the information they agree with rather than the information that's true. Why get something that's confronting that I don't like? Why not find the video that tells me the universe is going to end in the opposite of the Big Bang, because that's what I think the right answer is. And I'm just going to ignore that stuff that Professor Schmidt did because I don't like it. Well, okay, we don't normally do that in cosmology, but we do it on vaccines. We do it on all sorts of other things. And that's a real problem. And that's a big problem. But ultimately, it comes from getting people to be literate, every single person literate in high school.
What advice would you give a high school student who's considering at least doing a science and possibly a science career?
Well, just do it. A. B. It's, people get all of their jobs, all these things. There are lots of jobs. You just have to realize the whole notion of what your future career is going to look like is completely uncertain. Now, I'll be honest, when I went and started astronomy, I did not expect to become an astronomer. I knew there were only 2,000 practicing astronomers in the world, some of the smartest people in the world. And I was a good student, but I wasn't the smartest kid at my school for a decade. I was one of the better kids of the year, right? So I went out just to do the best I could, and I knew I was going to get a bunch of things that were going to help me in life and get me a job of some description. And I was absolutely right. That is the right attitude. If you're going to do astronomy, maybe you'll become a professor of astronomy, but maybe you'll do something else. And what's really interesting is it's the journey of learning that I have found fulfilling. Winning the Nobel Prize, I didn't do science to do that. And so I would turn away winning the Nobel Prize for all sorts of things that happened on the journey to winning the Nobel Prize. Those are the important things I love about life. So enjoy it, and that's my main thing. Enjoy it.
Now onto a final last question, and it's an opportunity for you to share a little bit about something you're passionate about outside your field, and maybe something you can teach us for a couple of minutes. I do know, though, you have a certain interest in growing grapes and the products thereof.
That's right. So one of the great things you can do here in Canberra is I live on a little farm about 20 minutes from where I'm sitting right here in the middle of ANU. Something that we were able to buy when I was, quite young, 30 years old, 32, I guess. And so we grow grapes, Pinot Noir grape, and each year, that's sort of my therapy. I go out, try not to worry about the universe, and just deal with nature, grow the grapes, use a fair bit of chemistry along the way, some biology along the way. But ultimately, it's sort of an art form of trying to get things to grow well and then make the wine afterwards. And so we have just harvested our grapes for this year here in Canberra. The grapes have fermented, and I am strategically letting them sit for a little bit before I press them together, squeeze all the juice out, and put that juice in barrels as raw wine. And over the course of about 18 months, that raw wine will get better and better. All the yeast will settle out, and you will get something you can put in a bottle and be very proud of. I make much better wine than I ever thought I would. I thought I could make wine that was drinkable. I actually make really good wine, and that's exciting. The only problem is it sells out in about an hour, and I have lots of angry customers, and that causes me stress.
I was actually looking on your website, hoping to buy, because I like wine too, and hoping to buy a bottle, and yep, you got to be very quick to buy them. So clearly, you're very good at what you do. Thank you, Dr. Schmidt. I really appreciate you taking your time out of your extremely busy schedule, and certainly value the thoughts you've presented today.
Yeah, thank you, Paul, for your efforts. We cannot have too many great science teachers, and thank you for going above and beyond the call of duty.
Thank you so much.
Bye-bye.
Well, I hope you enjoyed this episode. Please subscribe to get notifications of up-and-coming interviews as well as my other physics content. My name is Paul from PhysicsHigh. Till next time.